Alright, all of these problems are going to solve for the present value, the value today of a single sum to be received sometime into the future. Alright, our first problem, Joe got sentenced to 30 years in prison. He thinks he'll need $1 million when he get out of prison, so he wants to sell all of his property today and deposit that in an account earning 7%. So how much does he have to deposit today in order to have $1 million 30 years from now? He'll be saving for 30 years. He's earning 7% on this money, and he wants to have $1 million, and there are no other intermediate payments. I'm going to go ahead and set this, highlight this, because that's what I'm solving for. The PV function, hit the FX button, rate, number of periods, payment, and future value. Hit the OK, and the answer is $131,367. Now, if he deposits $131,000 today, he's going to earn roughly $870,000 interest, so that between the interest and the original amount, he'll have $1 million 30 years from now. Our second problem, Nancy wants to bequeath $250,000 to the Citadel when she passes away 40 years from now. She doesn't want to forget, so she decides to set up a trust fund today. How much she have to put in the trust fund today in order to have $250,000 in the future? All right, the future value is $250,000. She's solving for present value. She's got 40 years to save, and the account earns 5% annual interest. And there'll be no other intermediate payments. Now, I'm just going to copy this down, because since I'm using cell references, it'll automatically do the calculation for me, and I can always check that. The rate, C24, number of periods, C23, payment, C27, future value, C26. Okay, and then the second part, if the fund earns 10% annual interest, how much would she need to put in today? Just copy this over and change that to 10. She'd have to put in a lot less money if it was earning 10%. She'd only have to put in $5,500 today, and then 40 years in the future, she'll have $5,500 she originally started with, plus about $244,500 of interest. What is the present value of a single payment of $100,000 to be received 20 years from now? A single payment of $100,000, and notice this isn't the PMT, it's a single payment, one time over 20 years at 10% compounded annually. 10%, no other payments, because when it says a single payment, that's a one-time cash flow. If it only occurs one time, that makes it either a PV or an FV. Alright. And so, what's the present value of 100,000 20 years from now? 14,864. All right, and then at 10% compounded monthly, it would be equals 10% divided by 12, which would take us 20 years with 12 compounding periods a year to 240. And you wouldn't have to put as much in there to end up with the same amount, because it's going to earn about $1,000 more interest over that period. And if we took this to, what do you need if it's compounded daily? Well, 20 periods, 20 years with 365 compounding periods per year, and that'd be 10% divided by 365. That'd be the daily rate. It'd be about $100 less if you went from monthly to daily. And our last problem. Danny just got a letter from a lawyer informing her she has inherited $100,000 from Uncle Olaf. He deposited the money way back when, and it has been earning 3% compounded quarterly for 40 years. Okay, so an annual rate of 3% compounded quarterly means it's been earning 0.75% every 3 months over 40 years with 4 compounding periods a year, and it grew to be $100,000. How much did he put in originally? $30,000. All right. And again, that's the beauty. If you set this up with cell references, you only have to do it once to solve for the same problem. Rate is in cell C48, number of periods C47, payment C51, future value C50.